Okay, hi. Let's talk about Transmission Control Protocol, or TCP. So as a quick review of why we need this protocol in the first place, remember that when we built IP, it gave us global connectivity, which allowed you to contact any computer in the world that was connected to the internet. However, IP is unreliable, and it provides what's known as best effort delivery, which means the IP network will attempt to send your packet to its destination, but it might not succeed. Your packet could get dropped, it could get corrupted, packets might be delivered in a different order that you sent them, and IP does not handle any of these cases. So therefore, if you do want additional properties on your packet, for example, you want to guarantee that packets are received correctly and in order, then you have to design a higher level protocol that builds on top of IP. So we will use IP as a building block. We'll automatically assume that there's already global connectivity, and we'll use that as a building block to try and design something that does provide reliability. So we're going to try and solve random errors and packet corruption, and we'll also try to solve packets being dropped or received out of order. So this is the goal when we're designing TCP. So at a high level, I would say the conceptual part of TCP is not too bad. It's something we could design together, and most of today is just learning how to actually implement all of the high-level ideas into a protocol that computers can speak. But at a high level, most of these questions we can kind of answer at a high level first. So for example, one problem that we haven't explicitly called out yet is that IP packets are limited in size. You cannot send a layer 3 IP packet that is 1 gigabyte of size. That's just too big for the network to handle. The network only handles packets of, say, 1,000 bytes or so. Therefore, if you want to send a longer message, you're going to have to break up your long message into small packets. And this is something that a higher level protocol, like this layer 4 protocol, is going to have to do. So when we're designing TCP, you have to take your large message, split it up, and then send the split up messages through the layer 3 network. And then whoever receives those packets will have to reassemble them in the right order. So this is good. Now the user doesn't have to split up the messages themselves. We'll just have this TCP protocol automatically split up messages on one side and reassemble them on the receiving end. So if we introduce the notion of splitting up packets, this also introduces the problem that packets can arrive out of order. So maybe you want to send the long packet and it gets split up, or maybe you just have multiple things you want to send. In either case, packets can arrive out of order. So how do you solve this? If you think back to the mail analogy or something, if I'm sending a bunch of letters and they might arrive out of order, it's a really stupid solution I could do. Maybe I could just go on top of each letter and I write that this is letter number 1, and this is letter number 2, this is letter number 3. So all I really have to do is just stamp some numbers on top of every letter that I'm sending, and then whoever receives my letters will be able to reassemble them in order using the numbers that I stamped. So TCP basically does the same thing. Every time you send a package or a letter or a piece of mail, whatever you want to think about, you'll stamp a number on top of it that indicates where it is in the order, and then whoever receives those packets just has to rearrange the packets in the order that your numbers prescribed. So you stamp that this is number 1, this is number 2, this is number 3, and it doesn't matter how they arrive at the receiver. They can reassemble 1 coming first, followed by 2, followed by 3. So that's the high-level idea. It's something that is fairly intuitive. Everyone just stamps numbers, and you reassemble things based on the numbers. Now, one more problem we have to solve is that packets can get dropped. You send a packet, and the packet just doesn't arrive at the recipient. Now, at IP, this is not a problem. We said IP was best effort. So if you want reliability, you'll have to build something extra on top of IP. So what do you do if a packet gets dropped? What do you do if you send a letter and it's not received? Well, you can just send it again, and send it again, and send it again until the packet is received. So how do you check if a packet gets received? We'll solve that by having the recipient send us some sort of acknowledgement or confirmation that the packet has been received. So now we're adding something new. Every time you receive a packet, you have to send a reply confirming that you received the packet. So if I send packet number 1, then you have to reply to me saying, I have received packet number 1. And when I send packet number 2, you have to reply saying that you have received packet number 2, and so on. And this is how I, as the sender, know whether or not I have to resend the packet because it didn't arrive, or whether the packet successfully arrived, in which case I don't have to resend the packet. So to solve the problem of packets getting dropped, we will introduce resending packets until they arrive. And how do you know when they've successfully arrived? You have an acknowledgement packet coming back. Now, there is one thing that people always ask when they see this, and they always ask, okay, what if the acknowledgement gets dropped? Okay, fair question. What if I send the packet and it arrives and the acknowledgement itself gets dropped? Well, in that case, I, as the sender, will think that the packet hasn't been received, so I'll just send it again and again, and eventually there has to be some point where there is a successful exchange of me sending a packet and you sending an acknowledgement. So even if the acknowledgement gets dropped, I just send the packet more times until there's some point where I send a packet, you send an acknowledgement, and all is well. It does mean you might get the packet multiple times, but not too big of a problem. You can just discard any duplicates. So that's how we solve packets getting dropped. We introduce acknowledgements, and now as long as I send the packet and you send an acknowledgement, that's how I know that the packet was successfully received. So that's basically it. In terms of TCP design, it's just all the stuff on this slide, and everything we're doing after this is trying to get all of this into a protocol that computers can speak. But at a high level, these are all the ideas you have to know for TCP.